So hello guys, I am your teacher for today. And for today's discussion, we are going to discuss the different conic sections such as the parabola, the ellipses, and the hyperbola. But let us first know our objectives of the day. First, at the end of the day, we are going to determine which particular graph are we going to have. Second, we are going to learn how to graph and plot points. And lastly, we are going to look at the equation and change it into standard equation. So now we have the parabola here on the left and on the right. So we have this equation of y squared equals 4px, and on the right we have the equation of x squared is equals to 4py. And this happened when the vertex is at the origin of the parabola.
Oh my God! Wow!
So now we're going to identify on where to plot the focus. So always remember that the focus is always towards the vertex. And when we go away p units from the vertex, that is what we call the directrix. So for the directrix, we have here the equation for the left parabola, which is x is equals to negative p. And for the right parabola, we have y is equals to negative p. So for this parabola on the left, always remember that when p is positive, our parabola will always open to the right. And when p is negative, our parabola will always open to the left. On this right parabola, or our vertical parabola, we have p is equals to positive, which our parabola will open upward. And when p is negative, our parabola will always go down. So now, we'll proceed to the example for the parabola. And here, we are going to identify the coordinates of the vertex, the focus, and write the equation for the directrix. We are also going to have the graph and calculate the latus rectum. So we have the equation of y minus 8 squared is equals to 12 times the quantity of x plus 2. So for the equation, we can see that this is in the form of y squared is equals to 4px. But since we have the value for y and x, this means that the vertex is at the form of h and k. So as we have the vertex of h, k, so our basic equation for this is y minus k squared is equals to 4p times the quantity of x minus h. Where 4p is equals to 12. So later on, we'll discuss what are we going to do to calculate the p. Since our vertex is not at the origin, we have the focus of h plus p, k, and for the directrix, we have h minus p. So now, let's find the vertex. Given in the equation, in the form of v, h, k, we have the vertex of negative 2 and positive 8. Why? Because negative 2 is associated with the x values here, and we're going to change the sign for this. And negative 8, we are going to change the sign to positive 8 so we can have the k value. And now, since 12 is equals to 4p is equals to 12, we are going to divide both sides to cancel p. And we can have 12 divided by 4 is equals to 3. And our p is equals to 3. Since our vertex having the value of negative 2 and positive 8, we can plot the point. And to get the focus, we have to go away towards the vertex at the 3 units because we get the p value of 3. 1, 2, and 3. And we are going also to go away p units to get the directrix. 1, 2, 3. Located at this point, we can conclude that x is equals to negative 5. and our focus is at the point of 1, 8. And to check, we have to discuss later on the formula in getting the focus and the directrix. So now let's check. For the calculation of the directrix, we have the formula of x is equals to h minus 5. And having the formula of x is equals to h minus p, we have the value of h for negative 2 and p, we have 3. Negative 2 minus 3 is equals to x is equals to negative 5. So, we can see that we get the x is equals to negative 5 and our directrix here are x is equals to negative 5, meaning our graph is correct. And for the focus, we have the formula of f is equals to h plus p, comma k. Since we have this formula of f, h plus p over k, and our h value is negative 2, and our p value is equals to 3, and our k value is 8. So we can have the point of 1 over 8. Let's see. Negative 2 plus 3 is equals to k. Since 3 is greater than negative 2, so our sign would be positive 1. And our k is 8. So, we have the focus of 1, 8. So now, we have the coordinates for the focus, which is 1, 8. We have the equation for the directrix, which is x is equals to negative 5. And we have the vertex of negative 2 and 8. Let's now go to the latus rectum. And it is always equal to 4p. And as we get p is equals to 3, 4 times 3 is equals to 12. And we have the latus rectum 1 and the latus rectum 2. So 12 divided by 2 is equals to 6. So we have to go down 6p units. 1, 2, 3, 4, 5, 6. And 6 units to this. 2, 3, 4, 5, 6. So, our parabola will look like this. So, this is our parabola for the given equation of y minus 8 squared is equals to 12 times the quantity of x plus 2. So now, let's discuss ellipses. It is a plane curve surrounding two focal points and what we call the foci, in such a way that from any points on the plane or the curve, the sum of the distances to the focal point is constant. So we have this major axis at the horizontal line and is equals to 2a. Same with the vertical line. And for this, we have the vertical line for this horizontal ellipses is equal to 2b and same as this one. Now, whenever we have the vertex being at the origin, we can have the equation of x squared over a squared plus y squared over b squared is equals to 1 at this horizontal ellipses. And for this vertical, we have x squared over b squared plus y squared over a squared equals to 1. So, this is the equation when the case is the vertex being at the origin. So now, let's discuss the coordinates for the major and minor vertices when the center is at the origin and when the center is in the form of h and k.
Nope.
Few moments later. 5 minutes later. 5 minutes later. 5 minutes later.
Oh my God! Wow!
15 minutes later.
So, for the horizontal ellipse at this graph, we can have the center being at the origin, and the coordinates for the focus would be positive and negative c, comma 0. And for the vertex or the major vertices, we have positive and negative a, comma 0. And for the minor vertices, we have v, 0, positive and negative v. So now, when the case is the center being in the form of h and k, we can have the coordinates for the focus of h, positive and minus c, comma k. And for the major vertices, we have h, positive and minus a, comma k. And for the minor vertices, we have h, comma k, positive and minus v. And now we'll proceed to the vertical ellipses. So now, as we have the ellipse for this vertical ellipse, we can have the coordinates for the center of 0, 0. And for the coordinates of the focus, we have 0, positive and minus c. And we have the vertices or the major vertices of 0, positive and minus a. And for the minor vertices, we have positive and minus b, comma 0. And when the case is in a form of the center being in a form of h and k, we can have the coordinates of the focus of h, comma k, positive and minus c. And for the major vertices, we have h, comma k, positive and minus a. And for the minor vertices, we have the coordinates of h, positive and minus b, comma k. So now we'll proceed to the equation and example for the ellipses. We have to identify the coordinates of the center, the vertices, the foci, and graph the ellipse. So we can have the equation of x minus 5 squared all over 9 plus y plus 3 squared all over 36 is equals to 1. So this equation is in the form of x minus h squared all over a squared plus y minus k squared all over b squared is equals to 1. So our center is not at the origin. So we can have this center of h and k. And as we can see, h, we get positive 5 and k of negative 3 because h is associated with x values of 5 and k is associated with the y value of 3. And now we're going to determine the a and b values, and always remember that a should always be greater than the b values. So we have here 36, which is a squared is equals to 36, and the square root of 36 is equals to 6. And for the b value, we have 9. And the square root of 9 is 3. So we get b is equals to 3. And now, since we get the a value and the b value, we can also calculate the c value. For the c value, we have c squared is equals to a squared minus b squared. So our a squared is equals to 36, and our b squared is equals to 9. 36 minus 9 is equals to 21. And the square root of 21 is equals to 4.58. So now, let's graph it. Since we have the center of 5 and negative 3, we can plot it downward. 1, 2, 3, 4, 5. 1, 2, negative 3. 1, 2, 3, 4, 5, negative 3. So we have the center at this point. Since we have this center, we are gonna go 6 units upward since our a value is 6. So 1, 2, 3, 4, 5. And we're gonna go 6 downward. So we have the point of 5, 3, and 5, 9. Negative 9. And our center is 5, negative 3. So to check if these plots are correct, we can now proceed to the v, h, comma, k, positive, and minus a for the major vertices. Since our h value is 5 and our k value is negative 3, positive and minus 6, which is the a value, we can now have the major vertices and minor of 5 and positive 3 and 5 and negative 9. So, our major vertices is correct. And so for our B value, we have to go 3 units left and right. 1, 2, 3, and so we can now have the minor axis at this point. So to get and to calculate, we have V, H plus and minus B, K. And for our H value, we have 5 plus and minus 3, negative 3. And our major vertices and minor is V, 8, positive and minus 3, V, 2, negative 3. So, since 5, positive 3, or 5 plus 3 is equals to negative 3, we have the major vertices of 8, negative 3. And for the minor vertices, we have 5 minus 3, we have 2, and the K value is negative 3. And that is our major and minor vertices for these ellipses. And now we can conclude that our ellipses how it look like. And now for the focus, we have F, H, K, positive and minus 3. Since our H value is 5 and our K value is negative 3, positive and minus the square root of 21, or as we have the square root of 21 to 4.58, we can directly write it down. So for the major vertices, we have 5, negative 3 plus 4.58, we can get 1.58. And for negative 3 minus 4.58, we get 7.58. 7.58. And this is the foci of these ellipses. So we can graph it here, 1.58, and at this stage, we can graph it here. And this is the example for the ellipses. And now, for the last discussion, we are going to discuss the hyperbola. But first, let us know what is a hyperbola. It is an open curve with two branches, the intersection of a plane with both halves of a double cone. So, for the horizontal parabola, it looks like this. And for the vertical hyperbola, it looks like this. So, whenever we have the vertex at the origin, we have this equation of x squared over a squared minus y squared over b squared is equals to 1. And for this vertex, we have the equation of y squared over a squared minus x squared over b squared is equals to 1. Opposed at this equation. And A is the distance between the center at the hyperbola and the vertex. It was always the distance to be considered. So for the vertices of this hyperbola, we have V, positive and minus A, comma 0. And our coordinates for the foci is equals to positive and minus C, comma 0. At this hyperbola, we have V, 0, positive and minus A, and the foci or the focus of 0, positive and minus C. So, as we always remember, the foci is always towards the hyperbola. So, we can put it here. So, this is our foci at this point. So, for the C squared, we can get it as 6 squared is equals to A squared plus B squared opposed at the ellipse, which is C squared is equals to A squared minus B squared. So, for the coordinates, C is the distance over the vertex of the foci coordinates. So, for the horizontal and the vertical asymptotes, we have the equation of y is equals to positive and minus B over A x And for this vertical, we have y is equals to positive and minus a over b x. And now, we are going to proceed to the example of the hyperbola. So for the example of the hyperbola, we have to graph the hyperbola, identify the coordinates of the center, the vertices, and the foci, and write the equation of the asymptotes. So we have here the equation of 16y squared minus 32x squared equals to 256. Since this is not in the equation of the standard form of y squared over a squared minus x squared over b squared is equals to 1, we're going to divide both sides for 256 to cancel and equals to 1. 256 divided by 16y squared, we have y squared equals to 16. And 256 is equals to 32 is equals to x squared minus x squared over 8 equals to 1. So we have here the equation of y squared over 16 minus x squared over 8 equals to 1. And now we can identify the a squared and b values for this hyperbola. So for the a squared, always remember that a squared is greater than 16. The square root of 16 is 4. And for the b squared, we have the square root of 8. Since 32 is equals to the square root of 8. So we can now directly solve for c. Since we have the value of a, which is 4, and the value of b, which is the square root of 8. So, the c squared is equals to a squared plus b squared. Since our a squared is equals to 16 and our b squared is equals to 8, we can have the c as the square root of 24. So now, let's draw the hyperbola. Since we draw the hyperbola, we have to travel a units, which is 4, up and down. 1, 2, 3, 4. 1, 2, 3, 4. And b units, which is 2.83. Since it was near a 3, we can conclude that it is here. So now let's draw a rectangle for us to determine the asymptote. So for the coordinates of the vertices, we have 0, positive, and minus a. Since our a units is equals to 4, we have the major vertices of 0, positive, and minus 4. And now we are going to determine the coordinates for the focus, which is 0, positive, and minus c. Our focus would be 0, positive, and minus the square root of 24. And the square root of 24 is equals to 4.92. And now, the last thing we have to do is to write the equation for the asymptotes. Since the asymptote is equals to y equals positive and minus m, which is the slope, times x. This would always be equal to positive and minus a over bx. And this would be equal to y equals positive and minus 4, the square root of 8x. So this is our equation . And these broken lines identify to know and write the asymptotes of our given equation. And that's end my discussion for today. Thank you for watching, guys. I am Maria Marcy Marte, your teacher for today.